Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Let's talk about how we can add and subtract rational expressions with unlike denominators. So to add or subtract two radical expressions with unlike denominators, find a common denominator. Rewrite each rational expression using this common denominator and then add or subtract. So there's actually two ways we could do this. The first way, if we think about having a common denominator, if we look at example number 1, notice that we have a denominator of 12x squared and x squared plus x. So the first method that we could use is essentially, notice that we have 8 in the numerator on the left side. So we could multiply 8 by the opposite denominator, so it would look like this. So we would say 8 times x squared plus x over, and now we could write 12x squared times x squared plus x plus, and now we're going to multiply the right numerator, x, by the opposite denominator. So x, and then this would be times 12x squared, and now we can write the same denominator on the right side. So 12x squared and then times x squared plus x. All right, so now what we have done is we have created a common denominator. So we need to just simplify what's on the top, break it down a couple steps, then we can just write what we have in the numerator over the same denominator. So now let's take example number 1 and let's simplify what's in our numerator, okay? So let's distribute here and also here. So let's go this way one step. So we would have 8x squared plus 8x, and then we would have plus 12x cubed. Now at this point, let's just write it over the same denominator. So we have 12x squared times x squared plus x. So now what I like to do, I'm going to go ahead and rewrite the numerator in standard form so that my variable or my exponents on my variables are decreasing from left to right. So it would look like this: 12x cubed plus 8x squared plus 8x, right? So I'm going to delete this part, and I'm just going to slide this piece down right there, okay? So if you notice in the numerator, what we're going to do is go ahead and factor out our greatest common factor. And also in the denominator, that binomial x squared plus x, we could also factor out an x, and that's going to help us simplify. So let's come down here, and we notice that we have an x in all three of our terms in the numerator, so we can factor out an x for sure. And our numbers, our coefficients are 12, 8, and 8, so the GCF there would be 4. So let's factor out a 4x, and that's going to give us a 3x squared plus 2x plus 2 in the numerator. And in our denominator, we have 12x squared. But notice what we said a minute ago, we could factor out an x from that x squared plus x. So I'm going to write it like that. And then this would be x plus 1. So now, if we look at what can cancel, 4 and 12 would reduce to 1 over 3. This x in the numerator can cancel with that x in the denominator. So our numerator would just be 3x squared plus 2x plus 2, and our denominator now would be 3x squared times x plus 1, okay? And that'd be our final answer for number 1. All right, now number 2, we're going to go with another method here. So basically we're going to go ahead and find the least common denominator and work with that, okay? So in order to do that, let's go ahead and factor our denominators. So we have 5x minus 1. Now we have x squared minus 3x plus 2, so what adds to negative 3 and multiplies to 2? So that's going to give us an x minus 1 and an x minus 2. Minus, we have negative 2x minus 1 in our numerator, and let's just factor out a 2 to get x minus 2 right here. So now let's think about what our least common denominator would be. We have a 2, we have an x minus 1, and we have an x minus 2. So now we just need to multiply each fraction by the factor of the least common denominator that it doesn't already contain in the denominator, right? So hopefully when we work it out, it makes a little bit more sense. So here we have 5x minus 1 over x minus 1 times x minus 2. Now if we look at our least common denominator, we already have an x minus 1, we already have an x minus 2, so the only factor we're missing from the denominator is a 2. So we're going to multiply this fraction by 2 over 2, and now we're going to go ahead and write our next fraction. So 2x minus 1 over 2 times x minus 2. Now, what factor from the denominator are we missing in this fraction? That would be the x minus 1. So we're going to multiply this one by x minus 1 over x minus 1. So now we're going to do the multiplication. Okay, so we're going to get 5x minus 1 times 2, so 10x minus 2, over, and let's just write the 2 next to our 2 factors in the denominator, so it looks like this. Now let's FOIL on the top here. So we're going to have negative 2x times x, so negative 2x squared, negative 2x times negative 1, so plus 2x, and then negative 1 times x, so minus x, and negative 1 times negative 1 plus 1. Now we can write the same denominator, so 2 times x minus 1 times x minus 2. Now we can go ahead and combine our numerators and write them over the same denominator. So I'm going to write it 10x minus 2, and then minus, and I'm going to put this in parentheses here, negative 2x squared plus x, right? 2x minus x would be 1x, and then plus 1. And now we can write this over the same denominator. All right, so now let's simplify our numerator a little bit. So we have 10x minus 2 plus 2x squared minus x and minus 1 over same denominator, 2 times x minus 1 times x minus 2. Okay, so now if we come over here, let's combine like terms in the numerator. So we have a 10x and a minus x, so that would be, well, before we get to x, we just have a 2x squared, right? So 2x squared. Then we said we had a plus 9x, 10x minus x, and then negative 2 minus 1 would be minus 3. So 2x squared plus 9x minus 3 would be our numerator, and that would be over 2 times x minus 1 times x minus 2. And that would be our final answer for number 2. Okay, and that's how we can add or subtract rational expressions with unlike denominators.